Today let's generate high voltage, and for that I am gonna show you a simple circuit. This is a ZVS driver circuit and it is a resonant oscillator and it oscillates with very little loss. Here's a typical schematic for a ZVS driver circuit. The driver circuit is very simple. This inductor with this capacitor forms a LC tank circuit and they oscillate at its resonant frequency. Imagine Q1 is turned on, so this point is going to be low, this point is going to be high. The voltage will be swinging up and down. Because there is this resonant circuit in the circuit, the voltage will go up and down. At the way down, this diode will conduct, turning Q1 off. Q2 will turn on and this point will go low, this point will go high. The voltage will swing up and down. At the way down, this diode will conduct, turning Q2 off. And the cycle repeats. Now we know the working of the circuit, and here's the circuit that I built on a 0 PCB board. For the high voltage transformer, you can purchase high voltage kits from Amazon and it contains one of these transformer. And because the transformer secondary is made up of very thin wire, I am using 14 turns on the primary side to limit the voltage across the secondary so the windings doesn't break down and arc together. Now I have hooked everything together. Let's try to play with the high voltage. Let's try to play music through plasma, and for this I have designed a very simple circuit. It uses 3 comparator and a transistor. This comparator is the sawtooth oscillator, this comparator is the audio amplifier, this comparator converts the audio into PWM signal and it goes to this transistor, and then the transistor can adjust the average power of the circuit. Here is the circuit connected. Here you can see the transistor and I am using 2 op-amp chips and it has 4 op-amps but I am only using 3, and let's try to turn it on. Hope that nothing will blow up. Well, the arcs are now tiny because now the circuit is trying to limit the power to the ZVS driver circuit. Now let's try to play music through plasma. For this, here's the audio jack and here's the audio source, and let's try to play some music. Now let's have some oscilloscope measurement, and for this I can wind some extra winding in the core and I can connect my oscilloscope to it and see the beautiful sine wave on it. Now I have connected my oscilloscope to the extra winding and let's try to turn it on. But it is kind of sine wave and you can see the frequency is about 17.8 kilohertz. And if I play with the circuit, you can see the frequency rising, and when I play with the circuit you will see that the sine wave has less distortions then. See? Now on the plasma modulator, let's try to probe the audio input signal and let's try to probe this comparator output signal and see it on the oscilloscope. Here's the music signal which is coming into the circuitry, and I probe the transistor and I can see somewhat of PWM signal in it. I can see some PWM signal in it, but it's not very perfect.